So potassium bromide is KBr, and because it's molten, you get potassium ions, and then you get bromide ions formed from that. Potassium ions, if we just find a bit of space, potassium ions, K plus, pick up electrons and form potassium. So one of the products has to be potassium, and the bromide ions, they form bromine atoms by losing electrons, but bromine has to be diatomic, and therefore you've got two of those. So the only products are potassium and bromine. So in this one, hinges on the fact that zinc chloride is soluble and zinc carbonate is insoluble. So when the zinc chloride is soluble, that means the ions are free, and therefore can move, and therefore will conduct electricity. With zinc, the ions remain as a lattice and are not free to move, and therefore will not conduct. So what we need to say here is that the zinc chloride is soluble, the ionic lattice is broken, and the ions are free to move, so it conducts. We could also just add, to confirm that with them, that the zinc carbonate is insoluble and the ions are not free to move. So the gas that burns with squeaky pop is hydrogen, and let's explain how this gas is formed at the cathode. So here you have got sodium chloride, but it's in solution. Therefore, you have got sodium ions from the salt, but you also have hydrogen ions from the water, because AQ means water, and that means it contains hydrogen ions. Of these two cations, the rule is that the least reactive is going to be reduced first, which is going to be the hydrogen. So explain how this gas is formed at the cathode. So we can say here that hydrogen ions are reduced first as they are the least reactive. And then I'm going to do it as an equation, but I put in words as well. So we have got H plus E minus goes to H. Remember that H is diatomic, so therefore you need 2 electrons and 2 hydrogen ions. And we can say here in words, the H plus ions gain electrons to form hydrogen. Okay, so to get the marks in this question, there's just 2 marks for this. We need to make sure we've labelled the power supply, a DC power supply. We need to make sure that the wires are connected, and then we've got the electrodes sitting in the electrolyte. Okay, to get the marks, that's all we need to do in that question. So we need to explain a couple of things about the electrolysis experiment. The first one is the anode gets smaller. So if you remember, the anode is made from copper, and what happens to the anode is it breaks down to form copper ions, and by doing that it releases electrons. So we would say here that the anode gets smaller because copper atoms form copper ions which go into the solution. And if you remember, because this copper atom is losing electrons, this is also an example of a oxidation reaction. The cathode gets larger because the opposite happens. So the cations are attracted to the cathode. They gain 2 electrons, and that forms copper metal. So that is an example because they're gaining electrons of reduction. So all we've got to say here is that copper ions gain electrons to form copper atoms. And the solution remains the same shade of blue in this situation because the copper ions in this top reaction here are being formed and the copper ions are being taken out of solution, but they happen at the same rate. So all we need to say here is that the concentration of copper ions remains constant as ions are added and removed from the solution at the same rate.